All right. Number 4, if the measure of angle 1 equals 3x plus 20, the measure of angle 2 equals 6x plus 25, and the measure of angle 4 equals 5y minus 5, then find the values of x and y. So first I'm going to mark my picture up. We know the measure of angle 1 is 3x plus 20. Here's angle 1, 3x plus 20. Measure of angle 2 is 6x plus 25. Angle 2 is right here, 6x plus 25. And the measure of angle 4 is 5y minus 5. Angle 4 is over here, 5y minus 5. How many lines are crossing in the picture? 2 lines crossing, which means there is no transversal. To have a transversal, you need 2 lines that are being cut by a third line. We only have 2 lines crossing here. Because there is no transversal, we can't have alternate interior, alternate exterior, consecutive interior, consecutive exterior, or corresponding angles. But we can still have special angle pairs. There were 2 special angle pairs that we learned way back in August that we have when we just have 2 lines crossing. What are those special angle pairs that we can have when there's 2 lines crossing? Vertical angles and linear pairs. What's the relationship between vertical angles? They're congruent. What about linear pairs? Yep, they're supplementary. They add to 180. So when I'm looking at the 2 angles that have x, because that's what I'm going to have to find first, are these 2 angles vertical angles or a linear pair? Linear pair. So they are going to add up to 180. So I can say the measure of angle 1 plus the measure of angle 2 equals 180 degrees, and then I substitute in the place of the measure of angle 1, I put 3x plus 20, drop my plus sign down. In the place of the measure of angle 2, I put 6x plus 25 equals 180. Then I combine my like terms together. 180 is the only thing on this side of the equal sign. Everything over here just gets added together if it's a like term. We don't do the opposite operation because we're staying on the same side. So I combine 3x and 6x together. That gives me 9x. And then I combine 20 and 25 together. That gives me 45. So 9x plus 45 equals 180. Then I subtract 45 from both sides. And I get 9x equals what? 135. 9x equals 135. And then I divide both sides and we get that x is 15. All right, so there's solving for x. To find y, I can use either vertical angles or linear pairs. What's the vertical angle for angle 4? 2. So I could set these 2 equal. What's the linear pair for angle 4? 1. So I could add these 2 and set them equal to 180. So I've got 2 different ways that I could find the measurement of y. Do you guys want to do vertical angles or linear pair? Vertical sounds good. So angle 4 is congruent to angle 2. That's the first thing I'm going to write down. Angle 4 is congruent to angle 2, which means the measurement of angle 4 is equal to the measurement of angle 2. In the place of the measurement of angle 4, we put 5y minus 5. In the place of the measurement of angle 2, I put 6x plus 25, which would be a problem if I hadn't already done this work over here. because I need to substitute x in. I need y to be the only variable there. So I would have 5y minus 5 equals 6 times 15 plus 25. What is 6 times 15 plus 25? 6 times 15 is 90. And then 115, you just have to add the other piece onto it. So yes, 5y minus 5 equals 115, because we have 90 plus 25. Then I'm going to add 5 to both sides. So I get 5y equals what? 120. And then we divide both sides by 5. What is 120 divided by 5? 24. So y equals 24. Nicely done. What else would you guys like to see from the test review? Yes. Number 12, absolutely. Number 12. Determine whether the lines below are parallel, perpendicular, or neither to the given line, y equals 1/8 x minus 17. So parallel will have the same slope. Perpendicular will have opposite sign and reciprocal. And what does reciprocal mean again? Yep, we flip. We flip our fraction over. All right, so let's look at this line that they gave me. Which of these two numbers is the slope? 1/8 is our slope. So the parallel slope is going to be exactly the same, 1/8. The perpendicular slope is the opposite sign and the reciprocal. Well, what's the opposite sign from 1/8? Negative. We need a negative. And then instead of 1/8, we would have what? Yep, we would have 8/1, or just 8. Because I take my fraction and flip it over first, and then if I can simplify it, I do. So this is what I'm looking for in the spot where m goes. Remember, we're looking at the form y equals mx plus b. Where m is the slope. So for A, what is the slope? 8. Is that my parallel slope? Is it my perpendicular slope? No, because it doesn't have that negative, so we would say neither on this one. What about B? What is the slope there? -8 is the slope. So parallel, perpendicular, or neither? Perpendicular. And what is the slope on part C? 1/8. Parallel, perpendicular, or neither? Parallel. Fantastic. Yes. Number 6? Absolutely. Let's go look at number 6 next. If the measure of angle B equals x plus 47 degrees and the measure of angle E equals 3x minus 11, then find x, the measure of angle F, and the measure of angle H. All right, so one piece at a time, we're going to mark our picture up. B is x plus 47. So this angle right here is x plus 47 degrees. And E is 3x minus 11 degrees. E right here is 3x minus 11 degrees. If my lines are parallel, then I'm going to be able to make relationships, congruent or supplementary, between my special angle pairs. Are these lines parallel? How do we know? Yes, it's got these little arrows on it. These little arrows right here mean parallel. And so that means this line right here is my transversal. Is angle B an interior angle or an exterior angle? Exterior. What about angle E? Interior. So I have one of each. I have one interior and one exterior angle. Are they in matching corners? No. I have upper right-hand corner here and I have upper left-hand corner here. There's no name for this one, which means I have to find a different relationship. So I need to find something that's either the same size as angle B or the same size as angle E. Which one did you say? C. Angle C and angle B are vertical angles, so C is the same size. So that means C is also x plus 47 degrees. Do I have a name for C and E? Yes. What do we call these two angles? Consecutive. Interior or exterior? Interior. Consecutive interior angles. And what is the relationship for both of the consecutives? Consecutive interior or consecutive exterior has the same relationship. They're supplementary, yes. And supplementary means they add to 180 degrees. So I can say the measure of angle B plus the measure of angle C equals 180 degrees in the place, sorry, not B and C, that'd be C and, sorry, I wrote the wrong thing. I got ahead of myself. The measure of angle C plus the measure of angle E. So sorry, guys. I was adding B and C, but those are verticals. I messed up. We're adding our two consecutive interiors, which is C and E. C is the same size as B, so I substitute in x plus 47 in the place of the measure of angle C. In the place of the measure of angle E, we put 3x minus 11, and then equals 180. All of this stuff over here is all on the same side of the equal sign, so we just combine it together. I combine x and 3x and get what? 4x. And then I combine a positive 47 with a negative 11. What will that give me? 36. So 4x plus 36 equals 180. And then I'm going to minus 36 from both sides. What is 180 minus 36? 144. And then we divide both sides by 4. And what do we get? 36. So that's the first thing we were supposed to find. X is 36. We also want the measures of angles F and H. What'd you say? Well, that's a good question. Are F or H, are either one of those the same size as angle B? F is, because B and F are what kind of angles? Corresponding, yes. B and F are corresponding angles. So I can say angle B is congruent to angle F, which means the measurement of angle B is equal to the measurement of angle F. And of course, angle B is x plus 47. So x plus 47 equals the measurement of angle F. And we figured out that F is 36. So I do 36 plus 47 equals the measurement of angle F. Well, what is 36 plus 47? What is 36 plus 47? 83. So I get 83 degrees for the measurement of angle F. Measurement of angle H. H is right here. Can you give me another angle that would be the same size as H? E, because these are what kind of angles? Vertical angles, yes. Angle E is congruent to angle H, so the measurement of angle E is equal to the measurement of angle H. So 3x minus 11 equals the measurement of angle H. I'm going to put 36 in the place of x, so 3 times 36 minus 11 equals the measurement of angle H. And this right here, 3 times 36 minus 11, I can take that whole thing and pop it into my calculator. What do we get? 97. 97 degrees equals the measurement of angle H. What else would you guys like to look at? Number 5, absolutely. Absolutely. Complete the following 2-column proof. I'm going to fill in the easy stuff first. They got one of my easy parts. I know angle 1 is congruent to angle 8. That went right here in the top statement box. And my top reason is because that was given. I know the thing that I'm trying to prove is that my lines are parallel, so that goes down here. Line J is parallel to line K. And it tells me that I'm going to be using the corresponding angle theorem converse. The converse of all of these angle theorems lets me conclude that the lines are parallel. And I know I'm going to need them to be corresponding angles. Going back to my given, we know angle 1, this one right here, is congruent to angle 8, this one down here. Are those corresponding angles? No. I either need the corresponding angle for angle 1, or I need the corresponding angle for angle 8. 4 and 8, or 1 and 5. 1 and 5 or 4 and 8. It doesn't matter which one we pick. Are you guys okay if we do 1 and 5? All right, 1 and 5 are corresponding angles. Because I'm going to use the corresponding angle theorem converse, that means right before my final step, I want to talk about those corresponding angles. So I want to be able to say angle 1 is congruent to angle 5. I don't know why I can say that yet, but I know I want to say that because they are corresponding. And that's what I'm using right down here. Well, I don't know yet that these two are the same size. I made that statement, but I don't actually know it yet because I haven't given a reason for it. But I know 1 and 8 are the same size. What else do I know is the same size other than just 1 and 8? 5 and 8. Angle 5 is congruent to angle 8. Why are 5 and 8 congruent? Because they're vertical angles. So my reason for this is vertical angle theorem. And then Olivia, you said we can use what for angle 1 being congruent to angle 5? Transitive property. We have these two angles right here that are both congruent to angle 8. So this is our transitive property. Nicely done. What else would you guys like to see? Yes. 16? 13. 13. Number 13, write two equations in slope-intercept form for the lines that are parallel to and perpendicular to y equals 4/3 x minus 2, which both pass through negative 24, 10. So first things first, slope-intercept form is y equals mx plus b. My answer needs to have that form. And I will give you this formula on the test. I'm sure you guys remember it from Algebra 1, but you'll have it as a reminder also on your test. We want one line that is parallel to, so it needs to have the same slope. Bless you. Bless you. And one line that is perpendicular, that means opposite sign and reciprocal slope. What is the slope of the line they gave us? 4/3. Here's the slope. So what would my parallel slope be? 4/3. Parallel slope is 4/3. What will the perpendicular slope be? Negative 3/4, yes. Opposite sign, so this one becomes negative. And then we flip our fraction over. And we want both of these lines to pass through the point negative 24, 10. So I have an x1 and a y1 right here. We're going to use this for both lines. We need to use point slope form because we know what we want the slope to be. For both of the lines, we have different slopes. And we have a point that we want it to go through. Point slope form of a line is y minus y1 equals m, and then parentheses x minus x1. I will give you that formula on the test as well. We're going to use that same formula twice. Once for our parallel line and once for our perpendicular line. What am I going to put in for m for the parallel line? 4 over 3. Perfect. And then I bring down my parentheses and I have x minus, and I have my equal sign here. What goes in for x1? Negative 24. So I have x minus negative 24. Over on the other side of the equal sign, I have y minus, what goes in for y1? 10. So y minus 10 equals 4 over 3 times x minus negative 24. What happens when we subtract that negative? Turns into a positive. So I have y minus 10 equals 4 over 3 times x plus 24. Is that in y equals mx plus b form? No. Y equals mx plus b has no parentheses. So I'm going to need to get rid of the parentheses. How do I do that here? Distribute, yes. We're going to distribute the 4/3 inside the parentheses. That means I'm actually going to bring my work down here because I'm running out of room. So I have y minus 10 equals 4 over 3x plus, what is 4 over 3 times 24? 32. Almost in slope-intercept form. What do we still need to do? Add 10 on both sides, yes. So I would have y equals 4 over 3x plus 42. That is the equation in slope-intercept form for my parallel line. Y equals 4/3 x plus 42. Perpendicular is almost the exact same process. The only difference between what we just did and my perpendicular line is what I put in for the slope. What goes in for m here? Yes, negative 3 over 4. But other than that, because we're using the same point, I'm going to put the same things in for x1 and for y1. Bring my equal sign down. So I have y minus 10 equals negative 3/4 times x minus negative 24. And just like on the other one, minus the negative turns into a plus. So I have y minus 10 equals negative 3/4 x plus 24. Now what? Bless you. What now? Distribute. Negative 3/4 gets distributed inside here. I'm going to bring my work down and around again. So I have y minus 10 equals negative 3/4 x minus what? Minus 18. Then we add 10 to both sides. And I get y equals negative 3/4 x minus 8. That is the equation for my perpendicular line. Y equals negative 3/4 x minus 8. All right. Got 10 more minutes. That's enough time for 1 or 2 problems depending. Yes, Mara. Number 11. Absolutely, we can do number 11. You are given the line 1/3 x minus 6. Before I even go on and read the other parts of the problem, I am going to graph this line. What's the first point I put down if I'm going to graph that line? -6. And it goes where? On the y-axis. This is my y-intercept. So I put -6 on the y-axis, right down here. And then we use the slope of 1/3. Here's my slope. So the 1 is my rise, and the 3 is my run. And when we run, we always run to the right. So I'm going to go up 1 and right 3, up 1 and right 3. I got to the edge of the graph, so we're going to back everything up. Down 1 and left 3, down 1 and left 3. Then I grab my straight edge, and I sketch a line through those points. All right, so that is my given line. Part A, I want a line that is parallel. What do we know about parallel? Same slope. So what will the slope be here then? 1/3, yes. Parallel slope will be 1/3. And it says it needs to go through the point -4, 2. So we're going to plot this point first. -4, 2. -4, 2 is going to be right here. And then use the slope to find more points. So from that point that we plotted at -4, 2, I'm going to go up 1 and right 3, 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 and hit the edge of my graph. And then I go down 1 and left 3. I can get one more point on there. And then I can take my straight edge and draw through those points. This is my parallel line. Bless you. I put my given line on the graph before I put my parallel line on, so that when I see my parallel line and my given line together, I can check to make sure that they look like railroad tracks. These should look like two lines that are never going to touch. Part B, I want to kind of do the same thing, except I want a perpendicular line. What do we know about perpendicular? Yes. Opposite sign. And reciprocal. So what happens when I take 1/3 and I give it the opposite sign and make it the reciprocal? -3/1 would be my perpendicular slope. And I want it to go through this point here, 1, 6. So we're going to plot this point first. So 1, 6. Right here. And then we will use the slope to plot more points. So down 3, right 1. Remember, we always run to the right, even when our slope is negative. Down 3, right 1. Down 3, right 1. Down 3, right 1. Down 3, right 1. I got to the edge of my graph. I can't go backwards at all because I was already on the edge of the graph on the other side. So then I use my straight edge to plot through those points. There's my perpendicular line. Nicely done. We have 5 minutes until the bell for the announcements. I have enough time for one short problem. $15? Yep. Number 15. We have another proof. They filled in my first statement box, but I can fill in the first reason. My first reason is because it is given. I want to prove that line X is parallel to line Y, so that comes down here. X parallel to Y. It says we are going to use the consecutive interior angles converse. So let's go find the two angles that it talked about at the beginning, angle B and angle E. So here's angle B, and here's angle E. I want consecutive interior angles. Is B an interior angle? No. So I'm going to need another angle that is interior. C. Are B and C the same size? Yes. Angle B is congruent to angle C. Why? What'd you say? They're vertical angles, yes. So vertical angle theorem. Vertical angle theorem. Are C and E consecutive interior angles? Yes, perfect. C and E are consecutive interior angles. Well, B is the same size as C, right? I know that B is supplementary to E. If C is the same size as B, then what could I say down here? Yes, I can say angle C is supplementary to angle E. C right here is taking the place of B. When I look at line 3, what I just wrote on line 3, do I have a congruence symbol here? No. Then why am I allowed to make this replacement? Substitution. This is my substitution property. Beautiful. All right. Answer key for the test review is posted in Canvas. If you go to today's page and scroll to the very bottom, you can find the answer key there. So if you go to modules, what module are we in right now? 3B. So when you go to modules, you want to make sure you're in module 3B, and then you will scroll down pretty much to the bottom. Tuesday, 9:30, review for module 3B test day 2. That's what you want to click on. And then you scroll down to the very bottom of the page. The module 3B test review answer key is right here. And it does have all of my work shown on it. So anything that you would be expected to show on the test or anything that would confuse you as you're trying to figure out my answers are right here. Also, later today, after we have had periods 2, 3, and 7, I will post videos for periods 2, 3, and 7 along with period 1.